Hello, how are you doing? Welcome to the second video of the series. In today's video, we are going to focus on a few important aspects of ReactJS. We are going to understand how events works. We are going to understand how virtual DOM works. We are going to understand how reconciliation and diffing algorithm works. So today we'll hit 5 questions, and in these 5 questions we are going to understand all these concepts together. Are you for this? Okay, let's get started without any further delay. As part of the part 1 of this series, we have discussed questions from the React Foundations, JSX components, state and props. In part 2, we will be focusing on form handling, we'll be focusing on event handling, virtual DOM, these areas basically. These are pretty important aspects of React.js library. If you're learning React and if you're attending interviews, you will be getting questions from form handling, event handling, how virtual DOM works, what is reconciliation and things like that. So let's focus on this part and see how do we master some of these questions. It's time for our first question. The first question is, how will you create a React form with a single change event handler? Okay, how will you create a form in React with a single change event handler? That's the question. Now this question has various parts in it. When you're answering this question, you have to think about what is form. We have to talk about what is form, what are form elements, what are exactly event handlers, and we're talking about single handler method. So how and why it is required and how to kind of get it, right? So these are the things that we'll be covering in this question. Now, the first thing that I want to touch base over here is let's begin by understanding what are form fields. These are basic things. Like if you are working on HTML web for some time, you know what is form field. This particular picture shows some example form field. For example, we have first name, email, password, color, address, city, state, etc. And a button, submit button. There's a checkbox as well, right? And in HTML, when you write this one, you write it in a way input type text. In the previous one is a text box, email box, input type email, password, a text area is like this. So these are the HTML elements that actually gives you this input power, right? So when we are developing React application, we're talking about React form, we are also going to talk about HTML form, because all these elements, HTML elements that we are having right now, based on this, the React form, React elements has been created. In the previous video, we spoke about control input, right? The control input, the ones which are actually managed by the state, not by the DOM directly, not by the reference directly, if you remember that. So each of this input field in React is managed by state. Now considering that, next thing that you have to think about, the change event handler. What is event handler? For each of this input field, these are called input field because the user has to input something to it. And once user input something to these fields, it has to react to it. It means certain action has to happen. So we have to handle each of the user interaction for these input fields. So one of the such interaction can be change interaction, means the value of the input field is changing. So there is a text field. Now you're typing something into that, the value is changing. There is a select box, you're selecting something from that, the value is changing. There is a checkbox, you're marking something as check, the value is changing. So for each of this item, for each of these changes, we have to perform some action, and for that this handler should be defined. Now what we're going to do is next is I'm going to show you an example, and then we'll get into the code of that example and explain how we can handle all these events from each of this input, despite that each of the inputs are way different, with a single change handler function, and why we should be doing that as a best practice in React. Okay, so let's do that part. Take a look at this application closely. This application has got a form. The form is at the left side. It has bunch of input fields like full name, email, password, and so on. The right side is a panel where we show the preview of the inputs that you will be entering over here, and it will be creating this JSON object. We'll be kind of filling up this JSON object. And also, not only that, whatever input you're providing, based on that, we'll be creating a sentence over here. Okay, so let's first run this one. So full name, let's try Tapas. You're seeing that the JSON is getting updated. We are also having this input thing over here. Similarly, we can also fill Tapas at email.com, then some password. I'm not printing the password below, but it's coming in the JSON. What's the favorite color? Let's select some color. So you see the favorite color is coming over here, also the color code over here. Address, India, city, Bangalore, state, Karnataka. I don't think Karnataka is there. Okay, solid liquid gas. So I'll select solid and let's do some zip code maybe. Okay, and then check me out, check the checkbox. So based on every responses that I have made over here, what I'm seeing basically happening is, the value we have extracted out, and then we are able to create the JSON based on the value. We are also able to do something with the value over here. We're creating like a story below, right? Now, when I was inputting the value in each of these input elements, I had to handle that input, right? And while handle that input, the thing that I was doing is basically reading the things that user is inputting from here, and then keeping that in some variable or somewhere, and then utilizing that variable or that fact, that state, to form this JSON, to form this one. Now, you may think like, hey, I can actually add a change handler to this. I can add a change handler to this. I can do to this. But if we do this, think about the number of input we have: 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means you need to attach 9 change handler and 9 functions to take care of this. No, that is too much. What if tomorrow another 10 comes? That means you will be managing 19 functions. No, that's not good. So what we'll be doing now, for each of these handler, we are going to have one single change handler function, and in that change handler function we'll be handling all these inputs together, right? So let's see that code next. So now we are looking into the code, and we are looking into the code of the application I just now showed. So first let's take a walkthrough, then we'll be talking about the single change handler. The walkthrough is simple. I have a form and I'm using here React Bootstrap, a library for this application, which is like wrapper over some of this regular HTML aspects, reactified stuff. So instead of this form, you can just use the HTML form. It's kind of same, right? And so inside this form, I have a text box of full name, and then I have email, then I have password, I have color. So all these things, whatever you have seen, each of this form are, each of these form fields are there. And then I have preview component that you have seen the right side, the preview was coming. Now what is the crux of it is like, for each of this form field that we are seeing over here, the key point to achieve this, a single handler to achieve this one, you have to make sure that you add a name attribute to each of these inputs. A name attribute to each of this input. Okay, why? Because using this name attribute, you should be able to identify each of this input element. So if I have this name as email, using this email, I'll be able to identify this email field. Similarly for color, similarly for password. Now this name can be anything. You can give anything of your choice the name, but there is only one thing that you have to remember. When you create your state variable, so you also have to create your state variable over here, right? Because when you are changing password, when you are changing email ID or first name, you have to hold that data somewhere, right? So that you can actually display it in the preview. So where do you store it? One thought might come in your mind that I'll be creating state variable for each of this input. For example, I have a state variable as email, I have a state variable of first name, I have a state variable of password, color, or things like that. No, don't do that. When you are working with form and you are working with this larger form, instead of having individual state variable, work with objects. So if you see the state variable that we have declared over here, this is our state variable, an object. So if you see const state set state equals use state, I'm initializing with the object, and the object is having property which is indicating or associated to each of the fields. Now this is what I need to remember, that keep the name of these keys as the same as each of the fields, the name attribute. So if I go to the first name, this first name I'll be able to find, sorry, let me just go up once again. I just scroll down a bit. Yeah. So full name. So if I go to the full name, this full name will be exactly same as this name. If I have email, it should be email over here. If I am giving email 123, I should have the name as email 123. You get the point? So this is how we will be doing. Why? Because this is going to enable me for using a single handler instead of using the multiple change handler for each of them. Now, let's go to the handler part. So if I see for this one, I have an onChange event. OnChange means when you change something in the input text box, something has to happen. What has to happen? That should be defined inside this function. Now, if you see for each of this input box, the function is exactly same. For everywhere, it is handle change. I am not doing like, handle select box change, handle city change, handle address change, or handle password change. No, I want to have one single change handler. So I have done the handle change. Now let's go to the handle change function where all the magic happens. So what we are doing over here, simple thing. Handle change by default will have the event passed as a parameter, right? For every event, we'll have the event object passed as a parameter. Now, what we can do is like the moment we do event.target.name, it is going to give me this particular name for each of these things. If the event happens on this, event.target.name is going to give me the email. Event.target.value is going to give me the value of this particular input field, the current value. Event.target.value as number is going to give me the value of a field which is like of integer type or number type, right? Event.target.type is going to give me whether it's what kind of input box it is, and if it is a checkbox, then input.target.checked is going to give me whether this particular thing is checked or not checked. Okay, so now what I'm doing, I'm getting the event object. From the event object, first I'm checking that whether I'm dealing with a checkbox. If I'm dealing with a checkbox, because if you remember, our form is having a checkbox. If I'm dealing with a checkbox, I will retrieve the value as event.target.checked. It will give me true or false. If it is not checkbox, because other than checkbox, for every other field that we have, to extract the value, I can use event.target.value. Had I added one number type input field, I would have added another condition saying if it is number, then give event.target.value as number. Okay, as simple as that. Now, whatever the value I get, I store it inside this value. Now I will modify the state. This state I am modifying using event.target.name, which is nothing but this name, and this name is also same as the key of my state. I am modifying that particular state's key value using this particular value, and using this destructuring to make sure that new instance gets created so that my state actually gets updated, right? So when you are mutating state, in React, you are using object or array, you have to make sure that you mute it in a way where a new instance of this object will be created, and then only you set, so that the equality, whenever the equal happen at the background, it find out, okay, this is change, there is a time for me to change the state. React actually change the state. So we are having a single change handle.change. With that, we are actually extracting the value. And as we are managing the state with this key name, which is same as the name of the input field, I am modifying the property over here with the help of this name value and just changing that particular thing. So when handle change function gets called, say for color, once it comes over here, I'll be getting the value of the color that user is selecting. Event.target.name will be color. So in the state object, I'll go and find out, okay, color. Okay, this is color. Set the value of color to the current color. Same thing happened for all the input boxes. And then as I have this state value now updated, what I go to this preview this particular component, which is written over here, is simple component preview. Let me just go to preview once quick. It's at the top. Yeah. So what happened when we're going to the preview? Basically, preview just take, you're passing that state as a props, you would have seen, and then we are extracting this as a data, and then we are reading what is the full name, what is the email, what is the color, what is the address, whatever value we're just printing. And the JSON part, whatever I showed in the application, we're using a library called JSON Pretty, where you can pass the JSON data and it kind of format it beautifully. So that's what it is doing. So I hope this was clear. It is a bit elaborated. I think it was required to explain this one. And if you are asked this question, like how are you going to handle the form event with a single change handler, your answer should be now, yeah, we can handle. and we should be handling it because the form might have many fields. In that case, having event handler for each of these fields doesn't make sense. Rather, we'll create an object and maintain that as a state in the component. We'll have the name same as the property of the object. We'll have single change handler, and whenever something change, we are going to modify the state and use the latest state value for do whatever we want to do in that particular component. I hope this is clear. Let's move to our next question. Our next question is, what are synthetic events in React.js? So this is one question we frequently ask to the candidates who come for interview, just to identify like whether first of all they recognize that React.js events are a little bit different than the regular JavaScript events or not, or do they kind of have that deep knowledge and understanding what exactly the synthetic events. So the idea over here is like to React uses basically something called a synthetic event system. What a synthetic event is like, now every browser's implementation for how things work or how things should behave is a bit different. Now today a lot of the things are standardized, but there are still some gaps in the way that browsers implementation has been made, from say Edge to Firefox to Google Chrome to Safari and things like that. Now React as a library coming in between and helping us to build application, the user experience should not go different across these browsers. So when things comes into picture, like you have to handle events, it should not really behave differently from browser to browser, right? So React has created a wrapper, okay, a cross-browser wrapper around browser's native event. That is what is called a synthetic event or the synthetic event system. It is nothing beyond that. So regular JavaScript events are there, but regular JavaScript events may behave differently from one browser to another browser. Now, as a React.js application, when it is kind of coming out, that difference should not be obvious to your user. So React has created a cross-browser wrapper around this browser's native event, and this is what is called synthetic event. Now, if you don't look into the React code, try to understand like how the event structure is, you won't notice this difference at all. For you, the difference is really not there. It works basically almost the similar way as the native JavaScript event, but one advantage over here is like React's synthetic event works identical way across all the browsers. So that is the biggest advantage. Okay, you don't have to really worry about it. One thing you would have noticed, like when you create an event or define an event for an element in JavaScript versus React, in case of React, the event handler names are with camel case. Okay, that is a difference. And then React synthetic events always bubble. So when you have the event bubbling mechanism, React's always bubble is synthetic events, right? So this is one of the difference that you can see from JavaScript native events to React events. For some of the JavaScript native events like focus, it won't bubble. But in case of React, it makes sure React took a call like it is going to bubble always. So there are some of the subtle differences between the native JavaScript event versus React synthetic event, but most of the cases it works like as it is. So you won't find much difference. But when this question is asked to you, make sure that you touch base on the fact that why it is created, because of the cross-browser wrapper support, and there are certain differences like the bubbling part that we just mentioned, and how we actually define the handlers with the camel case versus the all lower case in case of JavaScript one. So those differences you want to kind of call out very clearly. So that's the answer for this question. Let us move to the next one. Let's take a question about passing event handling logic from parent component. So in this question, we will learn about parent to child communication, and we also learn about passing handler as props. The question usually comes as how to pass event handling logic from a parent component. And this is quite obvious thing that we do in React application. We work for reusability and we try to pass the event handling logic from parent component just to make things reusable. We are going to see that as an example. But before we do that, I'm going to go back to this diagram that we have seen in the last part of the series, where how the components interact with each other. So consider these yellow blocks as components, and these blue dots are state in that component. State is the private data to the component, and these red dots are nothing but the props that get passed from one component to another component. So one way that a component can communicate with another component through data is using props. There are various other ways we'll catch up in the upcoming videos, but this is the way that we can actually focus on right now. Now, while we are passing props from one component to another component, we can pass any data. We can even pass event handler. So let us understand with example like how we can pass event handler and when you should be actually doing this, right? So let's do that. Let's take an example of this application. So I have an application where there is a text box and there is a button for sending email and there is a button for uploading files. Now let's enter some email ID over here and click on the send email. If I do that, you see in the console, there is a console log which says send email to whatever the email ID I have entered over here. And if I click on upload files, I am getting a log says upload files. Now these two buttons look identical, but they are different. Why they are different? Because they are performing two different actions, and of course the label that we see on them is also different. So it means this particular button we can actually reuse. We can create one button, we can reuse. What we need to pass to this button component is the label that we want to show on the button and the kind of action that it has to perform. In this case, the action is to sending an email. In this case, the action is uploading files. So when this action should happen, when I click on this one, the action should happen. When I click on this one, the action should happen, right? So in those cases, what I can pass is basically, I can pass the handler itself to this particular button component. So let's see the code, like how things can happen. Now this is my button code. I name it as big button, any name that you can give of your choice, and it takes two props. One is the label that we want to show on the button, the text, and the handler itself. Okay, and if you see, the handler function is associated and assigned to this on-click handler, on-click event handler. So you have an on-click event handler equals to this handler function. It means whenever I'm using big button in whatever the component that I'm using, I should be able to pass this handler down to this big button so that whenever there is an action happen on the button, we know like what to execute. So this piece of code and this component is completely reusable. Now let's see how we can actually use it in a parent component. So let's take send email for example. So this is the send email component where I have imported this big button, and you have the text box that you have seen right now. And we also have this big button. I'm passing two props. One is the label, which is like send email, and the handler props. With the handler props, I am passing the function that need to invoked when somebody clicking on the send email button. In this case, we are just printing a log. We can actually write a code to send the email, right? The actual sending an email, we can actually do that. So here what we are doing from the parent component, we are passing the handler function to the child component using the props. This is something that you may be doing when you look for usability. Try to see like when you are doing this, whenever the usability come into a picture for things like that, like this button, you should be doing this one, passing the props and passing the event handler through props. Similarly, if I go to the upload files, another component, here also the big button is a child component. I'm passing another label called upload files, and again its own logic for uploading the files. Here it's just doing a console.log, but you can always write a logic to upload a file to the server just by the clicking on this button. So in any of these cases, the big button code is not changed at all. The code remains same. With the label and handler is that what you pass to it. I hope it is clear. So once this question asks like why you want to do it, bring reusability as a factor definitely of component, and tell like how you can actually pass this. So hope it clarifies. Let's move to the next question. Our next question is, what is virtual DOM and how does it help? To answer to this question, we will touch base on few concepts like what is DOM, what is virtual DOM, and how does the DOM update takes place in React.js. So let's understand what is DOM. DOM is nothing but document object model. So what is document object model and how does it help? When you open a web page on your browser, what you do basically, you have the structural representation of the page on the browser in form of your HTML and the HTML structure. So if we see this bunch of HTML of tag here over here, consider that this is the page that you have opened on your browser. So it has an HTML tag, and then you have a head, you have title, and inside the title you have the text. Then you have a body. In the body there is a h1 tag and there is a p tag. H1 tag has text again, and p is also having its own content. Now this is HTML, right? So when browser renders this one, what browser does basically, it creates a tree. It creates a model of your HTML representation. Why that model is required, or why that tree is required? Because if that tree or model is not there, then it will be very difficult to make your page dynamic. Think about a situation where you would like to change this h1 tag from DOM to say DOM manipulation, a text, or you want to change this particular p tag text to something else, or between this h1 and p you want to add a new div tag. You want to do all this kind of operations. Now to traverse through this particular document, you need something, you need some amount of representation. And what could be better than a tree data structure? So that's why browser actually provide something called document object tree that represents the model of your HTML. So this is a similar thing, but the representation is entirely different. If you see over here, you have a doc type HTML. Here you have doc type. The HTML, there is a root node called HTML. Then there is a child node called head. Then there is a child node called title. Title is having a text. Similarly, body is having h1 and p. h1 is having a text. p is having a text. Now, when actually this representation renders, we get this particular HTML render view, right? So you have a DOM, which is like a h1, and then there's a p called DOM is document object model. So this is your HTML. This is where the tree representation of it, and this is this particular rendered view. Now, once you have this tree representation, JavaScript has a DOM API through which it can manipulate the DOM. Okay, through which you can actually add something into the DOM, or you can update a DOM, like you can update the text, or you can add any other element inside the body. You can tweak things in that tree all over the places. So this is about DOM. Hope that understanding makes sense. Now, when you talk about DOM manipulation, there are basically two major things. One is called DOM update, and another is called rendering or re-rendering. So, going back to the previous example, let's say that I'm going to change this h1 text DOM to say DOM manipulation. What I have to do? I have to traverse through this tree using JavaScript DOM API. I have to identify this h1 element. Then I have to retrieve the text of this h1 element, and then I have to update this text to the new text. Once the updation happens, this view will be re-rendered. That means if I'm changing like DOM to DOM manipulation, this h1 tag text will be re-rendered to DOM manipulation. So why? DOM manipulation means DOM update and re-rendering. Now this update part, whatever we do, it's time taking, but it is still okay because it's a tree data structure. Traversing through it, might be quicker than any other data structure. But every time you make re-rendering, that's kind of time consuming. So the overall DOM manipulation, the way we do, traversing through the tree, identifying the element, and then doing your manipulation might be a costly affair. That's the reason we ReactJS thought about like, okay, we won't be updating the DOM directly ever. Instead of that, we will have something called a virtual DOM. What is a virtual DOM? Virtual DOM is an in-memory representation of your DOM, and as it is in memory, if you update this virtual DOM, you are not really updating your actual DOM directly. Interacting with your actual DOM directly and doing a DOM manipulation or update is a costly affair because you are updating the things on the browser memory directly, and you are doing this re-rendering. Rather than that, if you have an in-memory object and if you are updating the in-memory object instead, it is much faster. So that is why the virtual DOM came into the picture. Virtual DOM is not same as DOM. DOM is browser's element. It's a document object model of the browser. Virtual DOM is React's item, which is React thought out of React's thought process, out of React's ideology, where they think that updating the DOM directly might be costly. Instead of that, let's create a representation of that, in-memory representation of that, and let's update that instead, so that the performance improvement will be always there. That's what the virtual DOM is. In the next question, where we talk about reconciliation and diffing, we'll understand how does virtual DOM will be more powerful and how some updates happen in virtual DOM. Let's do that in the next question. Let's tackle the last question of today's video. So the question is, explain reconciliation and diffing algorithm in React. This is very frequently asked questions in React interviews. Now this question is completely based on our understanding of virtual DOM, which we have seen in the last questions. So here we'll be discussing about what is reconciliation, and we'll also get into what is diffing. So first, reconciliation. If we look into the reconciliation definition, it looks like this. It says, React keeps the in-memory virtual representation of the actual DOM and keeps it in sync with a batch update. This process is called reconciliation. It's a bit heavy, right? But let's break it down. What we understood that virtual DOM is an in-memory representation of the DOM, and React doesn't update the actual DOM directly. Rather, it works on the in-memory representation of the actual DOM, which is nothing but the virtual DOM. So React gives the in-memory virtual representation of the actual DOM. That means it is virtual DOM, and keeps it with sync with the actual DOM with a batch update. What is batch update? We will look into that with example. But first, try to understand this one, that there is an actual DOM and there is a virtual DOM. So whenever there is some changes happening to the virtual DOM, the same change update has to be made into the actual DOM. This particular process is called reconciliation. Okay, this particular process is called reconciliation. Now, if there is an actual DOM and there is a virtual DOM, and there is a tiny changes, some portion of virtual DOM, and we have to keep our actual DOM in sync with the virtual DOM, we won't be really traversing through the entire actual DOM to make this update. Rather, we will do a differentiation between the actual DOM and virtual DOM, try to figure out like what exactly got changed, and we will make only that tiny update into the actual DOM. This differentiation is done with the diffing algorithm. So we are going to understand reconciliation and diffing algorithm visually right now, and I want you to pay special attention to it so that you understand this entire concept much better way. Okay, so first thing is an example. Let's take a bunch of users like Alan, Bob, Clark, Daniel, and Ethan, and their marital status. Alan says, yeah, he is married, where Bob is no, Clark is no, Daniel is no, and Ethan is yes. Now, if I have to change Clark's marital status from no to yes, and if it is in a kind of DOM hierarchy, I will be traversing from the top, changing for Alan, then changing for Bob, Clark, Daniel, Ethan, and things like that. Now, making this one tiny change somewhere, I am traversing through the entire DOM tree, which is not great, right? So that is where I'll be differentiating between what exactly got changed. Maybe Bob's data had got changed, just update that one. That's where the diffing algorithm come into picture. But let's see this thing in visually so that you understand it much better way. This is original DOM, what you see on the screen right now. Now, there will be a representation, in-memory representation of it, which is nothing but a virtual DOM, which you have seen already. Now, let's assume that a portion of virtual DOM has changed, right? This particular, element has got changed. So anything in this tree hierarchy that's got changed means anything under it, downstream, all its children are impacted, basically. Assume that there was a p tag and now we change it to a div tag, right? So anything inside that p tag would have got impacted because we have changed the parent tag. So this entire family has got impacted. Okay. So now what happens is like when we have to find out like what has been changed, these particular virtual DOMs, we have to make this update over here. So a copy of it will be created. An exact copy of this in-memory representation is got created over here. Now, what we'll be doing next is like we are going to see like, okay, this is what got changed. So let's do a diffing. Let's do a differentiation between these two and try to figure out like what has changed. So we are saying like, okay, this portion has got changed because of this. Now, once we identify, okay, this portion has changed in the virtual DOM, now it's my time that I am going to make this update to the original DOM. And the original DOM gets updated and things are complete at this point of time. So what happened first? First we had an original DOM, and for that we had an in-memory representation of virtual DOM. Now let's say the update happened over here. So we mark it that from this parent, all his children's, I have to kind of account for updation, and I won't make this update over here itself. Rather, I create a copy of this one so that I can make a differentiation between these two, and then I mark it, and this particular update I reflect on the original DOM as well. This differentiation is nothing but a diffing algorithm, and this process of keeping the original DOM in sync with the virtual DOM is called reconciliation. Now let us quickly look into diffing algorithm and try to understand what is diffing. We understood from the visual diagram before, but let's talk about things from the DOM side of view. So here we have a div tag and there is a p tag and then the div closes. And let's say the change happens such that the div tag changed to the section. So here for p tag there is no change, but its parents got changed, like this div becomes section. So as part of diffing algorithm, it will identify that though the p is intact but its parent got changed, that means it's time to tearing down this this DOM portion and then recreate this portion. So this is one use case where parent has got changed, the children didn't get changed, but because the parent got changed, only this particular portion will be teared down and then a new portion of DOM will be created, right? So that is how the diff happens, and then because of reconciliation, the update also takes place. Now let's take an example of another one. So here you have a P and a class name called greeting, and then there is a text. And here the change happened is like this particular class name from greeting, it become my greeting. Rest of the things are intact. So it means only the class name got changed. So in this case, the diffing algorithm finds out that, okay, class name is the only thing got changed, the element is intact, its text is intact. So it means it is just going to change that this particular text part of it in the entire tree. So diffing algorithm to identify what has been changed, and the part of reconciliation, it will make the actual update. I hope this diffing is also clear now. So that ends our final question of today's video. In next video, we'll be coming up with few more interesting questions. And if you have any comments or if you have additional questions on anything that you have learned so far, please put into the comment section so that we can get back with the answers. Thank you very much for watching this video, and thank you very much for learning. Take care.